This video is on triangle congruence. This is a review of the triangle congruence theorems that you discovered in the investigation. SSS stands for side, side, side. That says that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent to each other. And you can see that in this picture here that has the three sides all marked as congruent. SAS stands for side, angle, side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. And you'll notice that this angle here, recall what an included angle is, an angle that's between two sides, and all of these parts are congruent to each other, so we have a side, an angle, and a side, so those two triangles are congruent. ASA is angle, side, angle. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. Here we have an angle, an included side, and another angle of each of those triangles shown as congruent to each other, so those two triangles are congruent. And AAS is angle, angle, side. If two angles and the non-included side of one triangle are congruent to the corresponding two angles in the non-included side of another triangle, then the two triangles are congruent. So here you can see that we have two angles of this triangle congruent to two angles of this triangle, and the sides, corresponding sides that are marked as congruent, are not between the two angles. It's not an included side. So that's why it's called angle, angle, side. Then there are two triangle congruence theorems, in quotes, that do not work. One of them is side, side, angle. And here's a picture of it. While both of these triangles have two corresponding congruent sides, and you can see those marked, and a congruent non-included angle, so here's your angle and there's your side, side, angle, side, side, you can see that another non-congruent triangle can be formed that meets the same criteria. In other words, this side here could be the same length, but it could be kind of swung out to create more of a wider or more of an obtuse angle. So if two sides and a non-included angle of one triangle are congruent to two sides and a non-included angle of another triangle, then the triangles are not necessarily congruent to each other. So SSA cannot be used as a proof for triangle congruence. AAA stands for angle, 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 and this also does not work. While both triangles have all three corresponding angles congruent to each other, and you can see that marked in this picture here, they're clearly not congruent triangles. So if three angles of one triangle are congruent to three angles of another triangle, then the triangles are not necessarily congruent to each other, and AAA cannot be used as a proof of triangle congruence. And from the previous video, don't forget about Cpctc. Corresponding parts of congruent triangles are congruent. If two triangles are congruent to each other, then all of their corresponding angles and corresponding sides are congruent to each other. So in this video, we took a look at triangle congruence theorems. 4 of them that work, 2 of them that don't, and one of my favorites, Cpctc.